today we will look at a very simple problem, which is graph representation. So there are two forms of graph representation. First is matrix representation. So if there are n nodes in a graph, let us say 0, 1, 2, 3, 4, 5, 6. So there are 7 nodes. So a size of matrix of size 7 by 7 is required from 0 to 6, following 0 indexing. And this is how we represent the vertices. And how these edges are represented, like the edge from 1 to 3, let's consider this one. So the first rows and third column will be made 1 to represent the edge from 1 to 3. But this is a simple graph, this is not a directional graph, so the edges are not having a direction. So if there is edge from 1 to 3, then we are having an edge from 3 to 1 also. So what we do is, the third row's first column is also made 1. So if we consider this principal diagonal, then mirror to it as a mirror, then both sides are made 1, and the rest all elements which between those two vertices we are having no edge, those are 0. So those zeros are I have not depicted here. So this is quite simple way of representing a graph. So this principal diagonal elements are also considered to be empty, that is 0. So normally if we are not considering any self loops means like from 3 to 3, if there is an edge which starts at 3 and ends at 3, so those are called self loops, which are not allowed in a simple graph. So if they are not allowed, then whole of this principal diagonal elements are 0. And let us look at second way of representing a graph, which is adjacency list representation of the same graph. So 0, 1, 2 and 4. So from 0 begins a list which is 1 to 4, because 0 is connected to 1, 0 is connected to 2, 0 is connected to 4. So from each element, so this is an array of all vertices. First of all, we make an array of all vertices, and from each vertex edges are these next pointers are originating, and it is pointing to a whole linked list of the vertices which are adjacent to 0 in this case, to 1 in this case. One's adjacent vertices are 0 and 3. So it is like that. So this is again for the same graph, which is a non-directional graph. But so if there is an edge from 0 to 1, then 1 to 0 also there edge is there. But if we are considering a directional graph and only 0 to 1 edge is there, 1 to 0 is not there, then we need not include this one. We just include 1 in the list of zeros, linked list, and we need not include 0 in 1's linked list. So I hope this is quite clear. Thank you, friends.